of the main goals of most IT groups is to manage file servers efficiently while keeping them available and secure for users. As networks expand, administrators find it increasingly difficult to keep the users connected to the files they need. So, to help administrators address these problems, Windows Server 2003 included a DFS, or what we call Distributed File Systems. So what is Distributed File System? It allows administrators to group shared folders located in different servers by transparently connecting them to one or more DFS namespaces. So what are these DFS namespaces? So these are the virtual view of shared folders in an organization. Using the DFS tools, administrator can first select which shared folders to present in namespace. Secondly, designs the hierarchy in which those folders appear, and lastly, determines the names that shared folders show in the namespace.
The DFS structure. So we have these three terminologies to familiarize. First is the service, second is the server, and third is the client. Service is a software running entity on one or more machines and providing a particular type of function to clients. Second is the server. It is the service software running on a single machine. Third is the client. It is a process that can invoke a service using a set of operations that form its client interface. So using these terminologies, we say that a file system provides file services to clients. The distributed file system is a file system whose clients, servers, and storage devices are dispersed among the machines of the distributed system.
Simplified data migration. The DFS simplifies the process of moving data from one file server to another because users do not need to know the name of each physical server or shared folder that contains data. Naming and transparency. Naming is a mapping between logical and physical objects. For instance, users deal with logical data objects represented by file names, whereas the system manipulates physical blocks of data stored on disk tracks. Multi-level mapping. It provides users with an abstraction of a file that hides the details of how and where on disk the file is stored. When the latter is mapped to a lower level numerical identifier that in turn is mapped to disk blocks, this is called multi-level mapping. Transparent distributed file system. It hides the location where in the network the file is stored. Going step further with the concept of treating file as abstractions leads to this possibility of file replication. Given a file name, the mapping returns a set of the locations of these file replicas.
Naming structures. So first we have location transparency, in which the file name does not reveal the file's physical storage location. Naming schemes. So we have three main approaches on naming schemes. First is the location evident, in which the files are named by the combination of their hostname and their local name. It guarantees a unique system-wide name. Second is the mounting. It attaches remote directories to local directories. It assigns also the root of a remote file system to an already accessible directory. Third is the single image, in which all users see the same integrated name structure for all files.
Remote file access. Remote service mechanism is a transfer whereby requests for accesses are delivered to the server. The server machine performs the accesses and the results are forwarded back to the user.
Cache location. Where should the cached data be stored? On disk or in main memory? The advantages of disk caches. First, it is more reliable. It survives failures. Second is that it avoids reloading on recovery. The advantages of the main memory. First, it allows diskless workstations. Second is that it can provide faster access on client machine. Since server use memory caching, it allows single uniform mechanism.
Update policy. So we have three update policies. First is the write through. It is reliable on little loss of information in the event of a client failures. It is slow on defeating purpose of cache. Second is delayed write. It optimizes network traffic for successive writes to same hereby blocks. It avoids overhead for data that will be overwritten. 20 to 30% of data is defeated with 30 seconds. And lastly is the write on close. It works best for files open for a short period and susceptible to loss of data for files in long ride.
Consistency. Is locally cached copy of data consistent with the master copy? A client machine is faced with problem of deciding whether a locally cached copy of data is consistent with the master copy. A client machine determines that the cached data are out of date. If it is out of date, access can no longer be served. So, an up-to-date of data needs to be cached. There are two approaches to verify the validity of a cached data: the client-initiated approach and the server-initiated approach. Client-initiated approach. Client initiates a validity check. Server checks whether the local data is consistent with the master copy. The frequency of validity check of this is the crux of this approach, or the importance of this approach. Validity check can load both to the network and the server depending on its frequency. Next is the server-initiated approach. Server records for each client the part of files in the caches. When server detects a potential inconsistency, it must react. Potential consistency occurs when two different client conflicting modes cached a file. So, server must be notified when a file is open. Then the server can act when it detects that a file has been opened simultaneously. The choice between caching and remote service trade-off potentially increased performance with decreased simplicity. Here are some advantages and disadvantages of caching and remote service. In caching, many remote access handled efficiently by the local cache. Most remote access will be served fast as the local ones. In contrast of this, remote server method handles every remote access across the network. Penalty in the network traffic, server load, and performance are very obvious. Benefit from caching. When execution carried out on machines with either local disk or large main memories. In other hand, remote access on diskless, small memory capacity machines should be done through remote service method. Caching is where data are transferred in mass between the server and the client, rather than in the response to the specific needs of the file operation. While the remote server is just an extension of a local file system across the network. There are two approaches for storing server-side information when a client accesses remote files. First is the stateful server, and next is the stateless file server. The stateful service mechanism is client open files. In a stateless file server, it avoids state information by making each request self-contained. So in conclusion of this, the advantage of a stateful service is that the file information is cached in main memory and can be accessed easily via the connection identifier, while on the other hand, stateless file server cannot do so since they have a knowledge of the purpose of a client request. There are distinctions between stateful and stateless server in terms of file recovery because a stateful server loses all its volatile state in a crash, while a stateless server, the effect of a server failure, send recovery are almost unnoticeable. Why it is unnoticeable? Because a stateless server is a newly incarnated server can respond to a self-contained request without any difficulty. File replication. Replicas of the same file resides in failure-independent machines, improves availability, and can shorten service time. Replica of files on different machines is a useful redundancy for improving availability. Multi-machine replication can benefit performance too, since selecting a nearby replica to serve an access request result in shortened service time. Demand replication, reading a non-local replica causes it to be cached locally, thereby generating a new non-primary replica.
DFS or Andrew File System, a distributed computing environment designed and implemented in Carnegie Mellon University, later purchased by IBM and released as Transart DFC, and now is an open source, which is known as OpenAFS.
Andrew File System seeks to solve complex issues such as uniform namespace, location-independent file sharing, client-side caching with cache consistency, secure authentication via Kerberos. It also includes server-side caching via replicas with high availability through automatic switchover to a replica if the source server is unavailable, and one of its formidable attributes, which is scalability. It is targeted to span over 5,000 workstations.
Andrew File System distinguishes between a client machine, or also known as a workstation, and a dedicated server machines. For client machine, clients are presented with partition space of file names, a local namespace, and a shared namespace. For dedicated servers, or also known as VICE, it presents the shared namespace to the clients as a homogeneous, identical, and location-transparent file hierarchy. A local namespace is the root file system of a workstation from which the shared namespace descends. Workstations run the Virtue protocol to communicate with device and are required to have local disks where they store their local namespace. Servers collectively are responsible for the storage and management of the shared namespace. Viewed specifically, clients and servers are structured in clusters interconnected by a WAN. Each cluster consists of a collection of workstations on a LAN and a representative of VICE called cluster server, which is connected to the WAN by a router. The key mechanism selected for remote file operation is whole file caching.
Briefly, here's few additional issues in the design of Andrew File System. Client mobility. Clients are able to access any file in the shared namespace from any workstation. Second, security. Device interface is considered the boundary of trustworthiness because no client programs are executed on VICE machines. Protection. Andrew File System provides access lists on protecting directories and the regular Unix bits for file protection. And lastly, heterogeneity. Defining a clear interface to VICE is a key for integration of diverse workstation, hardware, and operating systems. Andrew File System Shared Namespace. It is made up of component units called volumes. A VICE file or directory is identified by a low-level identifier called FID. A FID is 96 bits long and has three equal-length components: a volume number, vnode number, and a uniquifier. FIDs are location transparent. Therefore, file movements from server to server do not invalidate cached directory contents. Location information is kept on a volume basis in a volume location database replicated on each server.
Andrew File System File Operation. Andrew caches entire files from servers. A client workstation interacts with VICE servers only during opening and closing files. Venus. What is Venus? It caches files from the VICE when they are opened and stores modified copies of files back when they are closed. Venus may contact VICE only when a file is opened or closed. Reading and writing of individual bytes of a file are performed directly on the cached copy and bypass Venus. Andrew implementation. Client's processes are interfaced to a Unix kernel with the usual set of system calls. Venus carries out path name translation component by component. Both Venus and server processes access Unix files directly by their nodes to avoid the expensive path name to node translation routine.
Venus manages two separate caches, one for status and one for data. It uses a simple least recently used or LRU algorithm to keep each caches. The status cache is kept in virtual memory to allow rapid servicing of stat system calls.
The data cache is resident on the local disk, but the Unix input and output buffering mechanism does some caching of the disk blocks in memory that are transparent to Venus.